Assalamualaikum and hello everyone. Welcome to CHM271, Chapter 3, Ionic Equilibrium. Ionic Equilibrium, Definition of Acid and Base by ARRHENIUS, BRONSTED-LOWRY and Lewis, and Types of Acids and Base and Conjugate Pair. Lesson Outcomes. At the end of this lesson, students should be able to define acid and base according ARRHENIUS, BRONSTED-LOWRY and Lewis, and identify conjugate pair of acid-base reactions. Acid have sour taste, vinegar contains acetic acid, citrus fruits contain citric acid, turn blue litmus paper to red, react with base to form salt and water. This is known as neutralization process. React with electropositive metals to liberate hydrogen gas. React with carbonates and bicarbonates to liberate carbon dioxide gas, and aqueous acid solutions conduct electricity. Base have a bitter taste, feel slippery. Many soaps contain base. Turn red litmus paper to blue, react with acid to form salt and water. This is also known as neutralization process. React with ammonium salt to produce ammonia gas, and aqueous base solution conduct electricity. This is the theories of acids and base: ARRHENIUS theory, BRONSTED-LOWRY theory, and Lewis theory. ARRHENIUS theory. The Swedish chemist Svante Arrhenius, 1884, proposed that acids are substances that dissociate in water to produce the hydrogen ions or hydronium ions. This is the chemical equations. We look at the hydrochloric acid, strong acid. When dissolved in water, produce the hydrogen ion and chloride. Base are substances that dissociate in water to produce hydroxide ions. This is the chemical equation of the sodium hydroxide. When dissolved in water, produce the sodium ion and also the hydroxide ions. The great disadvantage of the ARRHENIUS theory: many organic compounds such as amines and ammonia do not contain hydroxide ions but show basic properties in water. BRONSTED-LOWRY theory defines that acid is a substance, molecule or ion that can donate a proton, which is hydrogen ion, to a base. Base is a substance that can accept a proton from an acid. In other words, acid is a proton donor and a base is a proton acceptor. Acid-base reactions are reversible that involve proton transfer. This is the example. We look at this one is the water as the acid and ammonia as base. So the product of the acid is a conjugate base, and for the base, the product is conjugate acid. How we look at the BRONSTED-LOWRY theory. This is the conjugate acid-base pair, which is the sulfuric acid, BRONSTED-LOWRY acid. How we identify this as a BRONSTED-LOWRY acid? We know acid, the previous one is a proton donor. So when the proton donor, meaning that the hydrogen ion give to the base. So water here considered as BRONSTED-LOWRY base. And the product for the bisulfite ion become the conjugate base. And the hydronium ion become conjugate acid. BRONSTED-LOWRY theory: acid become its conjugate base when it donates proton. Base become conjugate acid when it accepts a proton. This is the chemical equation. We look at this acid, the hydrochloric acid. This is the strong acid and react with the water as the strong base, and when dissolved in water, produce the conjugate acid and conjugate base. So this is how you identify which one is the acid. The partner must be conjugate base, and for base, the partner is conjugate acid. So this is another example for the weak base and weak acid. For the ammonia, react with water, consider as the weak acid. So the product is the strong conjugate acid for the ammonium ion, and the hydroxide ion consider as the strong conjugate base. Water can function as acid or base, which is called amphoteric. Amphoteric substance can react as either an acid or base. So this one, water as acid and water here as base. This is the example of the acid conjugate base pairs. We look at this one, example of the acid nitric acid. We know the acid donate a proton, meaning that missing the hydrogen ion here. So the conjugate base is the nitrite ion. In aqueous solution, acid-base neutralizations can be represented by the ionic equation. So this is the ionic equations. The hydronium ion, or we call as the hydroxonium ion or ozonium ion, act as a Bronsted acid, which is donate a proton to the hydroxide ion. So donate to the hydroxide ion here. So the hydroxide ion acts as a Bronsted base, accepts a proton from the hydroxonium ion. Lewis theory. According to Lewis theory, acid is a species which can form a dative covalent bond by accepting an electron pair from a base. A base is a species that has an unshaped electron pair which can form a dative covalent bond with an atom, molecule, or ion. We look at the example here. A considered as acid, B base. So acid here can form a dative covalent bond by accepting an electron pair from a base. So this is how you consider as the Lewis theory for acid and base. Lewis theory, an acid is an electron pair acceptor. A base is an electron pair donor. A Lewis acid accepts a lone pair electron from water. So this is the water, considered as the Lewis base. So the hydrogen ion here will accept the electron pair from water and produce the hydronium ion. Neutralization is the formation of a dative covalent bond between a species that donates an electron pair, the Lewis base, and a species that accepts an electron pair, the Lewis acid. Acid-base reactions is analogous to a redox reaction. An oxidizing agent is defined as an acceptor of electron, whilst a reducing agent is defined as a donor of electrons. This is the example of the acid-base system: ARRHENIUS, BRONSTED-LOWRY, and Lewis. Definition and properties of acids and base. Strong acids, acids that completely ionize in solution. So this is the hydrochloric acid. When dissolved in water, completely dissociate to produce the hydrogen ion and chloride. Weak acid that incompletely ionize in solution. This is the example of the strong acid and strong pairs, and also the weak acid and also the weak pairs according to the strength. For the strong acid, dissociate completely, produce high concentration of hydrogen ions. For the weak acid, dissociate partially, produce low concentration of hydrogen ions. This is the monoprotic acid, diprotic acid, and triprotic acid. For the strong pairs, pairs that completely ionize in solution. This is the example of the strong pairs, sodium hydroxide. For the weak pairs, pairs that incompletely ionize in solution. So this is the example of the weak pairs for the ammonia. For the strong pairs, dissociate completely, produce high concentration of hydroxide ions. For the weak pairs, dissociate partially and produce low of concentration of hydroxide ions. Okay, try to do this tutorial. And our lecture will be continued to the part 2 of the chapter 3 Ionic equilibrium.